Hello, everybody. The first thing you did in this section was in measurement is that you measured an unknown distance. That was your investigation, and if you did a good job going through that, you know that's great because you're gonna have data to compare with what I'm gonna show you right now. So we're gonna go back to that investigation and see. Uh, what mistakes you might have made and how these terms accuracy, random error, precision, and systematic error apply to what you did in that lab. Okay, so now you have that experience, okay, and we're going to go back now and analyze it, all right? So you can see we're going to talk about strides right now, the first method. Measurement method for that unknown distance that you used. And you might have found that strides wasn't the best method, okay? You probably had to take over 10 strides, and within that, somewhere you went off. I mean, you're only human, right? All right, so this is what you did, right? Here's your method. I drew a little diagram of it. These are your footprints, right? And you took those strides from one chalk mark to the other, right? And just as a reminder, what you did using after you strided that distance to get that unknown distance, you took the length of your stride, right? You multiply it by the number of strides you took, right? And that got you how long the unknown distance was, right? Okay. So let's look at what I usually get from a class when we do this lab. And you might not have got exactly the same thing, but this is what I usually get, and then we usually just go through this conversation once we've learned these terms. So let's go through the conversation. I'm not here, so I didn't know exactly how far the chalk marks were apart, but let's just say in this video that whatever distance they were apart, they were really 13.4 meters apart, right? And you worked in 8 groups. You put all your data on a Google Doc, all right? And those 8 groups, say, got something like this, okay? One was way high, 18.5, 18.2, 17.6. They're a little above the actual length out there. Whereas maybe there was only one below it, you know? But generally, the average fell somewhere in between here in the 15 more range here, okay? Which is greater than the real length. So we know the average and the real length were different, right? I took an average here of this data, and you could go back and do it for your lab too. The average, I think you did that in the lab, the average is 15.9, much greater than the real length, you know. So our measurements are not centered around the real value. That means they're not what? They're not accurate, right? That means what type of error must have shown up. That's right, a systematic error. Good job. I heard you think it. Now, let's also look at the data in terms of precision, right? Precise, were they repeatable and consistent? Whether or not they were right or not, were they at least the same every time? Doesn't seem so, right? They're kind of spread out, right? So they're not precise. So that means what type of error did we also have? Good job. Random error also, right? So not precise and not accurate. Stride stinks, all right? They're not a very good measuring method. Unless, like Mr. Koenig, you could do the same exact stride every time, like you're like a machine strider, which you guys really aren't. Most of you aren't, I assume. There's a great range. That means there's a lot of random error. It's remember, random error always skews data up and down, right, from our average. So from 15.9, we went up, and we also went down to 13, right? So that's how we know there's a random error there. There's a good amount. Now, this doesn't have to do like our previous video with the amount of lines on a ruler, because with strides we didn't really use a ruler, right? But there's another kind of random error occurring that is spreading our data out. So right over here, let's kind of write down what type of random errors might have occurred. You already did a sheet where you kind of wrote down what you think were the random errors in striding, and I assume with this one you already got it. I hope you do. Just think about it. What could be random about striding that maybe can make your data too long and too short, right? And spread out your data. It's definitely like not all strides are what are the same length, and that's totally true, right? You guys, like I said, you're not machine striders, right? Uh, Sometimes you stride too long than the one you actually measured to calculate with, and then sometimes you stride shorter than that. And maybe those will cancel out, but generally, the way you walk is different than just the way you stand and measure your strides. So some of you were too long and some were too short. That's just generally what causes the imprecision. That randomness spreads the data out, makes it not repeatable, not consistent. However, our data was also not accurate, like we said, because the average measurement was different than the real length, right? So they weren't centered around 13.4. The measurements were rather centered around 15.9. Okay, so what type of systematic error skewed the data higher in general, made it go one way? What type of systematic error did that? Random errors don't make the data go one way, they make it go both ways. The systematic error, there must be a systematic error that made the data in general shift the average measurement higher. Well, my question to you is, how do you measure the length of a stride? How did you do it? I didn't tell you how to do it, okay? So, what was your method to measure the length of a stride? And was that method correct? Well, think about the way you stride. Every time you take a step, which counts as one stride in your method, every time you take a step, how many of your feet were added to that length? How many feet of your feet moved? You only have 2 feet. When you take a step, do you move 2 feet? When you take one step, no, you only move 1 foot forward while the other one stays still. I mean, these things, like, you don't think about it, but you have to. This was your method. This was your procedure. If you screw it up, your data is going to be wrong. You only move that 1 foot when you stride. So how should you measure your stride? Well, we went from here, when we moved that 1 foot, right? Only one of the feet moves. So how many of your feet should be included in your measurement of a stride if only 1 foot is moving? That's right, 1 foot. That's it. Some of you measured your stride like this. From the back of your back foot to the front of your front foot. How many feet are included in that measurement? That's right, 2. Back of your back foot to the front of the front foot. 2 feet are included in that stride. If you measured your stride like that, you're wrong, okay? Because when you move, you're only going to be moving that back foot forward. This one's staying stationary, right? So every time you stride, you're only adding 1 foot length. Some of you measure your stride, just the instep of your stride, right? What do I mean by that? Front of the back foot to back of the front foot. How many feet are included in that measurement? 0. 0 feet are included in that measurement. That means every time you actually took a stride, you stepped with 1, but you're counting it as 0. Are these random mistakes that we, are just say, I'm human? No, I can't fix that. These are mistakes we can fix. We can calculate where we went wrong by just measuring how long our foot is and correcting our stride measurement, right? So I'm not going to make you go back and do it, but if you use 2 feet, all you have to do is recalculate the length of your stride using 1 foot, right? And then you're going to get an unknown distance that is a little lower because 1 foot is less than 2 feet, right? So a lot of you, I assume, use 2 feet. Some of you probably did it correct. Some of you, Mr. 14 right here is probably pretty proud of himself. Used only 1 foot in their length of stride measurement. Good job. You didn't make a systematic error. But you guys who use 0 feet or 2 feet, correct the length of your stride measurement so that it only includes 1 foot. Then you can recalculate your unknown distance and maybe it'll be closer to your real length. It will be accurate because you'll be centered around that real value. Will that get rid of your imprecision, your spread? No, you still can't take the same stride length every time. There's still random error.